Okay guys, in this video I want to talk a little bit about rhombi. And so rhombi is the plural form of rhombus. So we have one rhombus, two rhombi. Alright, so rhombi are parallelograms with four congruent sides. Alright, so we have four congruent sides. The angles may not necessarily, well, they usually aren't congruent. And so parallel sides and all four sides are congruent. So this is a side classification of quadrilaterals. Now, we have two theorems. If ABCD is a rhombus, then AC and BD intersect in a right angle. So let me draw this here. Okay, so in other words, these diagonals intersect in a right angle. Always, no matter how much you stretch this. So, and the second one is that diagonals of a rhombus bisect all the angles. So first, it's saying, the first theorem is saying that this intersection, these are all right angles. The second theorem is saying that for example, this diagonal bisects B and D and bisects C and A. So we can prove this all with one set of we can prove these at the same time. Now what we can do is that we know, first of all, the given is that if ABCD is a rhombus, so a rhombus implies that all these are the same. Okay. We also know that a rhombus is a parallelogram, so we know that this is true. Okay. So we have that given information. Now we know that these we know that in any parallelogram diagonals bisect each other. So in any parallelogram diagonals bisect each other. Okay, so we know that in any parallelogram, which rhombi are, the diagonals bisect each other. So by SSS, then we know that triangle AB, we'll call this E. So ABE is congruent to triangle, ABE is congruent to triangle, let's see here, BCE, which is congruent to triangle CDE, which is congruent to triangle CDE, which is congruent to triangle DAE by SSS. So all of these are actually congruent, okay? And so these are congruent. Now we notice that BEA, angle BEA, and angle AED, those are a linear pair. Those are a linear pair. But we know that these two angles are congruent, okay? So angle BEA and angle AED are congruent. So if they're a linear pair and they're congruent, then they're 90 degrees. So if one of these is 90, then all of them are 90. So that's how we prove the first part, okay? The second part is that the diagonals of a rhombus all intersect each other. So by similar logic, we have these congruent triangles. And if these triangles are congruent, then that means that their corresponding angles are congruent. So that means that this angle and this angle are congruent. We know that this angle and this angle are congruent, etc. So all the angles have been bisected. These are congruent and these are congruent. Okay? So all of these are due to the fact that we have congruent triangles by SSS. So both of these theorems are true. Let's move on to some examples. So again, the definition says parallelograms with four congruent sides. Well, we see that actually these are not congruent, so let's go ahead and make them congruent there. All right, now we have a parallelogram with four congruent sides. So what do we know about this? Well, we know that this angle, 3x degrees, must equal 90. So x is going to equal 30. All right. So this is 90. These are all 90 here. All right, 90, 90, 90. Okay, so those are 90. Now we also know that we want to find y here. So we know that this angle by our second theorem down here, we know that this is also going to be 30 degrees. So if this is 30, this is 90, then y is going to equal, looks like 60 degrees. Okay. So in our second picture here, we have, again, let's check this out. We have a quadrilateral A, B, C, D. It looks like the diagonals bisect each other. If diagonals bisect each other, that means we have a parallelogram. Okay. And we have one given right angle. Okay, so that means all these are right angles. So this is a rhombus, and so we want to find what x is. Well, we know that all the sides of a rhombi are the same. So if this is 5, then we know that x equals 5. Okay. I have two y's here. Okay, so let me make one of these. Let's make this z. Okay. So here we have y. And so we know that this is a parallelogram. Again, so this is DC is parallel to AB. So the alternate interior angles are going to be congruent. Y equals 15 degrees. All right. And finally, again, this is going to be a Z here. Okay. So that's a Z. Okay, so Z, we know that this is a right triangle, right? So Z, we have a right triangle with hypotenuse. Let me just draw it down here. 5, 4, and Z. Okay, so this is our situation we have. Now, hopefully by now you know that whenever we have this relationship, Z is going to equal 3. Okay, that's a 3, 4, 5 triangle. If you don't know that, then you have to do Pythagorean theorem, which says the sum of the legs squared equals the hypotenuse squared. So the sum of the legs squared equals the hypotenuse squared. So Z squared plus 16 equals 25. So Z squared equals 9. So Z equals plus or minus 3. But we know the distance can't be negative, so Z equals 3. So hopefully this gave you a little bit more information about rhombi. Thanks for watching, and join us again for squares.